Hi, it's Jan Beta, and today I'm going to try to resurrect an Amiga 1200 board that somebody tried to recap, but that went kind of wrong, as we're going to see. So this is a revision 1A Amiga 1200 board that Neil sent me. Thank you very much for that. I'm not sure if Neil attempted to recap this, but somebody did a very subpar job on trying to replace the electrolytic capacitors on this board. And other than that, it looks pretty good. There are some bits that I'm going to have to look at, like there's a solder blob here on this connector that probably shorts out some of the components there. I'm going to give you the tour of what I've seen so far. Okay, in this section here, the surface mount capacitors are at angles. I think some of the pads came off. There's the pads completely ripped off of this here. The through-hole capacitors are all wobbling, so they're not really soldered. I think the pads came off completely, so we're going to have to do quite some rework there. This, I think, isn't populated generally, so isn't much of an issue. As long as we get that cleaned up properly, it shouldn't be an issue. Here's the aforementioned solder blob. This electrolytic capacitor is also completely loose, not soldered to the board at all. Yeah, we're going to have to try to remove that. The little tab that plugs into the keyboard connector was removed, but Neil told me that he used it on another Amiga 1200 board that he got instead of this one, so we're going to find a replacement for that or just leave it off. Doesn't really matter if we have a working keyboard at this point because we don't have a working Amiga. Yeah, this also is loose, and yeah, let's look at the back side of the board. It came with the bottom shielding, which is quite nice. And by the way, I'm not judging anybody's work here. This is just... It is a pretty hard exercise to recap these boards. As you've maybe seen, I failed quite miserably recapping my own Amiga 1200. A couple of years ago now, I don't know, one of the first videos I made was attempting to recap my Amiga 1200. And I have fixed the faults in the meantime, but yeah, it didn't look much different from this one actually, so yeah. The through-hole capacitors don't make contact, and I think the pads are ripped. It's probably pretty difficult to see. Here's one of the through-hole capacitors, and that just wiggles. The solder blobs here wiggle and don't make contact with the board. I don't know yet if that's due to the pads being ripped there. There might be some traces that are cut here. We're going to take a closer look at that. Yeah, no idea if this can be resurrected. I don't even know if this worked before the recapping attempt. So we're going to have a lot of fun with this. Potentially this could be a longer term project. This board also didn't come with the kickstart ROMs, but I have plenty of those in my parts bin, even the diagram and things like that we can try in this once we have everything recapped. That's the plan for now. I'm just going to remove every single capacitor on here again. The electrolytic capacitors, the surface mount ones and the through-hole ones, and then look at the carnage basically, because with the capacitors in place I can't really see which pads are damaged and which traces are damaged. That's the first step. It's going to be tedious, but I'm going to remove all the electrolytic capacitors again and then have a look at the board. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs. They also do CNC machining, 3D printing, sheet metal fabrication. They can also populate your boards for you. Basically, they do everything the retro computer tinkerer needs in-house. Their service is excellent, quality of the boards is superb, and they are friendly people to work with. So I highly recommend checking out the link in the video description. Back to our Amiga. I think the reasonable thing to do would be to remove the through-hole components here first, with my desoldering station, being a bit careful about the traces around them on the bottom side of the board, and then I'm going to go in with my hot air station after masking some of the plastic parts around the capacitors and remove the surface mount electrolytic capacitors here. And then we're going to inspect the board a bit closer. Hopefully there's not too much damage to the board itself. Hope we can revive this. Hopefully a couple of botch wires are going to bring this back to life. Desoldering these should not be that much of an issue since they are already halfway out. So we're going to see. I think there is quite some carnage here. We're going to see. Okay, so that's my through-hole caps out. And the pads are actually, they look better than I feared. But we're still probably going to have to do some patching up. I'm just going to clean these holes with some solder wick, I think. And see. So yeah, the pads are still somewhat there. That's good, I guess. Yeah, that's completely missing. There's no copper there. That's not good. So I'm going in with some solder wick now to remove the remaining solder. Hopefully. Ooh, okay. These are nasty. Yeah, the one pad is completely missing there on the back side. But I think the connection is on the top side here, so that should be okay. I think this pad is completely ripped off. This pad's still there, which is nice. This looks like there's two pads missing here, but we can probably botch that. Yeah, that's going to be fun. Just let me remove everything I can. Yeah, I'm trying to be super careful with this as far as that's humanly possible. But there's already quite some carnage here. Yeah, that pad is also ripped. These here are completely ripped out, it seems. Yeah, it doesn't look great. But these should be pretty basic connections that we can probably resurrect. Just let me try and get this part here off. The solder splash there. That wasn't too bad. I think I got that off. There's a bit of solder left on the connector. I'm just going to clean this a bit with some isopropanol and a brush to see what we have. I guess we should desolder the surface mount stuff. Before I go in there with my hot air, I'm going to mask off some of the plastic parts like the keyboard connector and some of the chips around the surface mount electrolytics with Kapton tape, which is a heat resistant tape that protects the plastic parts ideally. So yeah, going to see about that. Nothing much to lose at this point, but I'm going to be super careful with this anyway. All more or less masked, the stuff around the electrolytic capacitors that could potentially get hurt. And I'm just going to go in with my hot air and try to remove these crudely soldered in capacitors here again. That's the next step, to the hot air station. Hot air is still, in my experience, the easiest way to do this, or the least destructive. But your mileage may vary, and there's other ways, of course, of achieving this. Oh, this smells fishy. So there were some original caps on there, I believe. Or the electrolyte has not been cleaned off completely. So we're going to give this another good clean. So I'm just heating the pads, trying not to get too much on the surrounding components. Just taking turns, left and right pad. And usually these come off quite easily after a while of heating. I'm going to do this for all of them. Okay, I think we have them all removed. Some of the pads look good, some not so much. Just going to clean these up with some solder wick and the regular soldering iron. And then we're going to inspect the damage. And of course you want to be super careful with the solder wick, but it's always good to remove the old solder. Of course it's quite easy to rip these surface mount pads off. Don't want to apply too much pressure. And there are ways to repair these pads. There's even special glue that's heat resistant and things like that. But I'm not going to attempt that, I think, because that's just a bit too sophisticated for my knowledge. I'm just going to try to run some wires, I think. If that's even possible, we're going to find out. Yeah, this is a bit corroded as well here in this area, which doesn't make things easier, obviously. So this was a quite badly corroded specimen, I guess, before the attempt to fix it. Yeah, I'm just going to clean everything up as well as I can with some IPA, some Q-tips, carefully going in there, and then we're going to see if this is salvageable. And of course, at this stage you also want to be careful, especially with Q-tips, because some lint of the cotton can get caught under the pads. So I like to use brushes more than Q-tips to get the gunk from these pads, because the risk of ripping a pad off is a lot less. But I'm still going to use Q-tips for the finishing touches to get the dirt actually away from the board here. And plus there are quite a few ripped pads here that are already gone, so I'm just going to try to clean that off. Basically all the devices that use surface mount electrolytic capacitors from this era, early 90s to mid 90s I guess, the surface mount capacitors were not really good at that time. So pretty much all the devices I've seen that are from that time period have leaky surface mount capacitors. So you might want to recap them rather sooner than later. The leakage from them eats through the traces and corrodes components, and all kinds of bad things happen. So you want to remove them at least, and then ideally replace them and make the devices work again. I looked at some schematics and some videos, especially one by Dave Poo, which I'm going to link in the video description, about what these capacitors actually do in this section here, which is the worst on this board. And there's actually quite a few we don't need if we are not planning to use the RF modulator. I think this is not really useful these days, at least not for me, so I think I'm going to remove this altogether. And then we have quite a few capacitors that only support the RF modulator, so we can leave this one out, we can leave this one out, and we can leave this one out, which is completely destroyed anyway. We don't need this one, this is not populated from factory. I don't know why the pads are gone. This one we do need, I think. This one we don't need. Yeah, we basically only have to repair this one. These two are not needed if we don't want to use the RF modulator. We have to replace this one and find a solution for this missing pad here, patch it up to somewhere it should connect. We of course need these two, which are basic voltage filtering for all kinds of stuff, I think. This one appears to be intact. I'm going to measure the traces there. And then we have this one here, which is also connected to the video circuitry. This is the video DAC, so converting the digital values to analog video in this computer. And this is the general Sony brand video encoder chip, which provides the composite and also the signal for the RF modulator, but we don't need that. So I think I'm just going to remove the RF modulator altogether at this point and just write on it A1200 RF. And I'm just going to desolder that, and then we're going to see if we can fix up the traces there, the ones that we need. So I'm just going to leave these out of the equation, which makes things considerably easier because there's only a couple of things we have to fix up. But first, let's try to get rid of this can altogether, shall we? That's not going to be easy because these are a huge heatsink in itself, basically. I'm just going to add some flux here and probably some fresh solder, and we're going to try to remove this thing. It is a bit of a workaround, but yeah, this is not going to make this useless at all. Maybe back to the regular soldering iron, just with the heat cranked all the way up. And of course you don't have to remove this. Maybe I'm just going to give up. But we might just have a chance here. Our RF modulator should be more or less loose now. There we go. Yay! And now the access to the parts we want to get to is much easier as well. So yeah, top side looks pristine basically. On the back side, I think I burned some of that pad at least. But these are just anchor points for the RF modulator, so there's absolutely no... It's all connected to ground anyway, so there's not going to be any issues with that. Okay, great. I think it's time for putting some new SMD caps on there, which I'm going to do with my regular soldering iron, some flux, and yeah, some regular solder. Yeah, I have a leftover capacitor pack. I don't even know where this came from, but these should be all the capacitors you need for an Amiga 1200. So I'm just going to put these in there, I guess. I've made a couple of videos about this process, so I'm not going to go into much detail. This time you can just watch the other videos where I explain this in greater detail. I'm just going to go into how I'm attempting to repair the trace damage that we have here. That's going to be the interesting part for this video, I guess. Yeah, let me put the surface mount capacitors in there. I think I want to see where this trace here, which is ripped off, goes and where this is supposed to go, which is ripped off. The other pads look fine. I'm just going to check if the pads are actually connected to where they should be connected with my multimeter at this point, I think. I'm just going to see where this is supposed to go with the Amiga PCB Explorer, which is a very nice website. So here's the website I was talking about, and this pad is actually going to the video encoder chip. This is the pad that's still there, and this pad isn't there anymore. That goes to this here. So that's the video signal for composite, I believe. That goes to this rail here. So we need to connect that pad to this, which should be visible on our board. This is, by the way, this is not the same board revision that we have, but it's the one that's closest to what we have here, I think. It's just ground, is it? So we could possibly just connect this to this resistor. So this here should be connected to this. So this goes to the video chip. And this here should be connected to ground, I believe. Is this ground? So I just double checked with another Amiga board actually, and this pad should be connected to the little via that's straight ahead basically, so this one here, so from here to here. I think we can just run a botch wire there, and then this should connect to a wider trace on the back side of the board. Yep. And yeah, we're going to put the capacitor in, I think, and then connect the wire to the capacitor leg there. This should be a 22 microfarad capacitor here. Now we're going to make a connection from the leg on this side to the other side there, hopefully. I think I'm going to use this magnet wire. That's not so easy. Okay, of course this stuff is not made to be soldered like this. Possibly it would even make sense to put a through-hole capacitor there or something. This is not so easy. Yeah, no, that's not going to cut it, I think. So yeah, we're going to try to find an electrolytic capacitor through-hole one and stick one end to this and the other end to this. So let's see if we can actually fit one of these in there. Might have to widen the hole a bit there. just the tiniest little bit. Yeah, got it in there. Yeah, so admittedly this is quite the workaround, but it should be electrically perfectly fine. So I'm just going to solder that one in there, which is of course not the way this was intended, but it should probably do the trick. Yeah, I think that's in. Beautiful. Or yeah, not beautiful. Something other than beautiful. Yeah, as I said, this is not the way any of these pads are intended to work, but it holds. And I think we have a connection there. Yeah, this is ugly, I know. But the plan is to get this working again no matter what. And it was pretty badly destroyed. So maybe this is the way to go in this case. We're going to see if we can make the other pads a bit more elegantly. Ideally you would fix the pads actually, but these are so far gone that I don't see how that would work. With my experience and my tools that I have at hand here. So this should be connected to R238 on the board, on the backside. Yeah, which it is. This one is not even populated, but I'm going to solder it to that as well. So that is one workaround. More to come. So this should be connected to our video encoder chip. This side should be connected to pin 2 on the video encoder. Which it is. That's nice. Okay. And the other side should be connected to the correct spot on the board now as well. And now keep in mind that this is basically the only surface mount capacitor we need in this region. The other ones are all for the RF modulator, which we removed anyway. So if this one works, we're going to have a video out. Now the next tricky bit is this missing pad here. And that, maybe you can see the trace going here, should connect to this. This is a via that connects this to the other side of the board. I already scraped away some of the solder mask. And this via should go to the second pin on the top row of this here. Yep, which it does. So we can either connect this directly to the pin, but there's already a little botch wire connected there from factory, I believe. So I'm going to try to connect it to this via again. And I'm probably going to do the same thing as before with the through-hole capacitor. That might be quite a nice option, because this is pretty sturdy, the one we put in. So maybe we are going to add a bit of hot glue to those or something like that, just to fix them in place a bit better. But it's going to be way easier to stick a leg from a through-hole capacitor through this via and solder it to that, than to actually put a surface mount capacitor in there and run a wire. I think I'm just going to go with the through-hole capacitor. I see a lot of people screaming at me. Yeah, the legs just fit. Just going to apply some physicality here. At least that's going to be quite a sturdy connection, I guess. Positioning this nicely, shortening this side to where the pad ends. So let's double check if our connections are there from the capacitor. So the negative lead should go to this pin here. Totally does. And the positive lead should go to the via next to it, to this one here, I think. Okay, so that connection is there. Okay, that's our two worst parts done, I think, with the, with the workaround of using through-hole caps. It should work fine, actually. Yeah, let's do the other surface mount components, and I'm going to use real surface mount capacitors for those, because I can. The pads are all there, the ones we have to populate now. other pad came off. Another pad came off. That's not good. This one here. This one should be relatively easy to fix because there's a via right next to it. That was probably pre-damaged quite a bit. I was not that uncareful. I think that was the part that smelled fishy too. So that would make sense. That is connected. Okay, now for the through-hole capacitors that we have to replace. That's going to be quite fun. Not quite sure how I'm going to pull that off, but we're going to see. Most of them are connected on the top side of the board, I think, so we have to do some magic to connect them. Yeah, some of them are connected on both sides, I believe. That's going to be tricky, but we're going to figure that out with the PCB Explorer. Should be relatively easy to figure out where they are supposed to be connected. The only thing that's not going to work is to solder them in, because some of the pads are not going to hold. So the first capacitor, the positive lead, should be connected here, and it's also connected on the bottom layer here. Okay, so we can probably bend the leg and connect it to this or to this. And this is the negative of the large capacitor that is connected to the other side of this capacitor. So we should be technically able to solder this side to this capacitor on the back side of the board. And we also have to make a connection on the top side to this. It seems doable. Let's try. 1000 microfarad from my capacitor kit here. Yeah, we can probably just scrape away some of the solder mask here to connect it on the top side to this rail. That should be totally possible. And on the other side, it looks like the connection on this side of the board, at least, still there. Let's see. This is our ground layer here. Yeah, that's still connected. This one isn't, but can try to connect it to this trace here. So yeah, I'm just going to stand it off from the board slightly to maybe manage to get some solder onto that pad and on the leg there. That should totally be possible. Yeah, we made a connection there. Let's try the other side with the intact pad. Just going to heat this up nicely. And I think that should be that. Let's see where this connects on the bottom. 604 and C801. 801 is there. Okay, that's the one right next to it, so this should be connected to that capacitor right next to it. Can do. Can cut this off like here, so it doesn't short out with the others. So this should be connected to here. So I think we need to put a botch wire there. I think my magnet wire might work this time. Yeah, that is connected. That hopefully should be connected. Let's try. Okay, this should be connected from here to here. Yep. And this should be connected. Yeah, we have all our connections on this one, I think. So let's see what the other side should connect to. That's all ground. Yeah, so it's properly connected to ground. On to the next ones, I guess. We're going to do the next ones just the same. So this one is going to be a bit tricky because most of the traces are missing, and we are going to have to connect this trace to here, which is not populated, which should be pretty easy to do. And this little trace goes somewhere down here. I'm going to look at the bottom. Yeah, that's going to be more difficult. That goes up here. to a resistor on that side, I think on the top side of the board. This is looking at the bottom. This is a 470 microfarad capacitor. We're going to see. So here's our little culprit, and I already scraped away some of the solder mask. There's the trace here directly next to the hole, which has all the plating missing, and there's the trace here, which goes to this capacitor here, as you can see. So we're going to probably patch this up with the wire to here. And this one, I might just try to get a connection to this little piece of the trace here. I'm just going to tin the traces there that are exposed. And then I'm going to run some additional wires, I think. Getting my capacitor in there. Probably leaving the legs exposed a bit to be able to solder to them. Just going to bend it where the RF modulator was, so we can just run wires there. So just to give you a little idea of what I'm working with here. This pad here on the right side, from your point of view, this seems to have some through-hole plating still going on there. I'm going to check if the connection is still there to the places it should be connected. And this here is completely stripped, so there's no plating in there, so I'm going to have to run wire from this where it's supposed to go. This is not going to be super beautiful, but maybe it's going to work. That is very nicely connected, and that shall go here. Just puzzling my way here. Yep, that is connected. Let's see if we have an electrical connection. Yep, absolutely. And this supposedly goes here. So we're going to patch that up with another length of wire. This is going to take a while. I'm not sure if I want to show you all the details, the gory details. There we go, that's connected. The nice thing about this magnet wire is that usually you can just hold your soldering iron down for a bit and it's going to melt the little small amount of insulation that's on there. And yeah, then you can just connect it that way. So this should be connected to the pad next to the plus symbol there. And I'm just going to add some fresh solder to this resistor, and I'm patching this up. Yep, that's a nice connection, I think. Let's see. This leg is now connected again. Okay, yay! The bottom side of this is not connected. There's no connections on the bottom side, it seems. So we're just going to cut the legs here. Let's go on to the next one, which is this one. Okay, this one is a bit troublesome because it is connected to the internal layer, which is not very pleasant to get a connection to. We're going to figure that out as we go. I think the pad on the VCC is completely missing. The other one seems to still be there. Yeah, that one looks good. Let's see if this takes any solder. The other lead. I don't think so. There's no through-hole plating whatsoever going on there. Nope. Okay, according to the PCB Explorer, this negative signal, or it's not a negative signal, it's ground, basically. This is video ground, according to the PCB Explorer. Should go to here, little via here, and this via, apparently, is connected to this resistor here and to the ground, the general ground. So we can possibly just patch this up by soldering this leg here. That would be a good idea. So I'm just going to connect this to the ground plane by connecting it to where the RF modulator ground was. Or it still is there, the RF modulator is gone. So I'm just going to bend this here and solder it to this hole here, which was one of the ground connections on the RF modulator can. This should be doable. I think we have a connection there now. That is now connected. So that's our negative side. By the way, if you rip the inner layers, the risk of damaging the inner layers is pretty minimal, because where there are not supposed to be connections, basically the copper from the inner layer is going to be cut out. So I got a bit lazy and double checked with the other Amiga board that I have lying around here, which is also broken. And this should supposedly go to this R215 here. So we should be able to just run a wire to R215 there. So this is the closest component that I could find here. That is connected. And then this goes there. Cut this there. Yep, that should be connected. Yay, that is connected. This one should be reconnected now. Connected the negative lead to here and the positive lead to the resistor on the backside there, which should be connected on the inner layer to the video voltage supply, which is, as the schematics tell me, is the same voltage rail, 5-volt rail that the whole system is powered by, but it's separately laid out to be less prone to noise, I think. So it should be in that network even with that little resistor there. That's part of the video voltage. So yeah, let's go on to the last through-hole capacitor that's here in the middle of a lot of silk screen. Yeah, this is a tricky one. We still have some copper around here. We're going to figure out where that connects and do the same thing basically. And I think we are going to go directly to soldering it in, or at least as far as we can, and then connect it. That's way more elegant. Yeah, unfortunately, there's absolutely nothing that takes any solder in there. So, plan B. We're going to have to wire it up discreetly, basically. So our positive lead goes to here originally. So we can solder a wire to this here, which is a through-hole via connecting to this via. And the other side is just ground again. So that should be a bit easier. Yep. That's in there. I'm going to add a bit more solder here, just to make a better connection maybe. This goes to our capacitor leg, which I'm going to leave a bit longer to have some gription in the ripped pad there. So I'm trying to go around our capacitor here for a bit, kind of tying it. Yeah, that's on there and it's still in the hole. Dirty work. Okay, the other lead, that's our negative lead. That goes to the video ground, of course. Oh, that is a very normal ground connection there. Okay, that's good. So we have plenty of room to connect that. I'm just going to go with this via here. Just going to do the same with this lead. Cut it very short. And solder to that with some magnet wire. Ideally, this is the last connection that we have to patch up, but there might be a lot more. Yeah, that's on there. Yeah, okay, that is connected nicely. Okay, connection from here to here should be there. Yes, and it's connected to ground. Okay, it's not connected to this ground. It's a separate ground, really. That's good. Okay. So, I think we have all the stuff patched up. I'm just going to double and triple check everything. And then maybe we can try to power this on even. That's going to be hilarious. Yeah, that indeed seems to be everything. All I could find, at least. I'm just going to put some kickstart ROMs in there and try to power this on, I guess. At this point, I checked some more connections here with my multimeter and everything seems to go according to plan. No shorts that I can find. There might still be some, I'm not sure. But yeah, everything looks relatively promising. I don't even know if this worked in the first place, so no idea what we are going to find. Maybe there's going to be another video troubleshooting this Amiga 1200. Maybe they recapped it because it didn't work. Not sure. I'm going to do a little cut and then see you while trying this. Just a little aside, I'm in the process of putting the kickstart ROMs in here. The low one goes in the upper socket and the high goes in the lower socket actually. There were some really bent little tabs here on this socket on the top one. So I hope this makes good contact. I'm also going to add some contact cleaner for good measure, I think. If we don't get anything, this might be an issue as well. So we might have to replace these sockets. And you want to leave the first 2 pins here on this side empty for these kinds of ROMs. So these are working Kickstart 3.0 ROMs. I think these are even the ones from my Amiga 1200, my original ones that I had from back in the day. So these should be fine. So I connected up my monitor and a power supply that is a known good power supply. It would be some kind of miracle if this worked right away, but it would make me incredibly happy. Okay, fingers crossed. Watch this. Turning on. It's giving me a PAL signal, and the Kickstart 3 takes a while to boot up, if it works. Yes! It boots up fine! That's incredible! That is one of the most incredible repairs I've done so far with the board that was that destroyed. Nice! Okay, we're going to have to put this through some tests, but this is really promising. Okay, this thing just booted into Amiga Test Kit, and the mouse works. How about that? Okay, let's check the CAA and chipset. Yep, all tests passed. Memory test. Test all memory. Yeah, this appears to be a working Amiga 1200 again, believe it or not. I didn't believe that this would be a relatively easy fix. It's not an easy fix at all, but it kind of seems to have worked. Memory seems to work fine. Music works. Filter works. Nice! It's a fully working Amiga. Yeah, that's pretty nice. Let's test the video. This is a very basic test. If we can see the menu, basically the video should work fine. This seems to be a working Amiga again, which is surprising and super cool, obviously. Yeah, Tarikan also works, which is my go-to test for Amigas. As you maybe know, if you've watched probably any of my other Amiga videos. Can't believe this was fixable at all. But that just goes to show that it's always worth taking a look at lost causes like this. And if everything's lost with the board, there's still the re-Amiga boards and things like that. Yeah, it just works. Super nice. This makes me so happy. Yeah, I guess that's it for today. I am very happy with the result of this. It doesn't look very nice, as you've seen, but with the amount of patching that I had to do, I still can't believe this worked right away after double checking. I checked the connections again with my multimeter off camera, but other than that, I didn't have to redo anything or anything like that. Everything you've seen me do remained as what it is now. I'm just going to add some dabs of hot glue to the large through-hole electrolytic capacitors that are a bit wiggly, and I'm also going to try to fix the wires, the botch wires that I added a bit with hot glue. And then there's going to be another episode where I actually turn this into a full Amiga 1200 eventually, because I have some parts. I have the keyboard from my original Amiga 1200. I have case parts. I think several of them are a bit broken, but I think I can fix it and make this into a fully working Amiga 1200 with a case, with a keyboard, and maybe I'll add a Gotek or a disk drive, haven't decided yet. Yeah, this is going to live another day. Thanks again, Neil, for sending this to me, and hopefully this was informative and maybe a bit entertaining. Of course, there's better ways to fix these, more clean ways. As I said, you can also buy replacement boards for these and just move all the components over to the new board, which is an exercise that's not super easy, as you can probably tell. I'm pretty happy that this was fixable in this way, and it should be pretty sturdy at this point. All the solder connections are okay, at least for the surface mount stuff. As I said, hot glue is going to hold the electrolytic capacitors, the through-hole stuff, in place. And that's going to be fine, I hope. Thank you so much for your time. Thank you for your thumbs and your comments. Special thanks, as usual, to the people who support me on Patreon or on Ko-fi or on the YouTube community page, memberships page. The links to that are in the video description. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.